All right, so we're going to now tackle question 3 of the 2019 practice exam. This is actually a pretty good one to go over. So they give us this function f and define it as continuous over the interval of -6 to 5. That's really important because they're just showing us -2 to 5, so it's very important to recognize that. The figure above shows a portion, right? A portion of the graph of f, sorry, consisting of 2 line segments and a quarter circle. So that's important. They indicate that this is a quarter circle right here. And that circle is centered at 5, 3. So we can maybe make that center over there just so we know for reference. So that's basically a quarter wedge. It is known that the point 3 minus root 5 is on the graph of f. So that's going to be this point right here, right? Where x is 3 and y is 3 minus root 5. I guess that means that the height of this is root 5. All right, so part A asks us if the integral of -6 to 5, so that means the entire graph from, let's just draw our imaginary line here and say it goes all the way to -6, right? And we don't know what this graph looks like, but they're saying if that integral from here to here, -6 to 5, is 7, find the value of -6 to -2, right? Find the imaginary integral here, right? Well, not, I shouldn't use imaginary since that means something else in math. And then show your answer. So basically, where we're going to find the integral from -6 to -2 is to take the entire integral, which they give us as 7, and then subtract this part, the portion they're actually showing us. And so we have to find the integral of this graph, right? So that's going to be, this triangle, this tiny triangle, this tiny triangle, this tiny triangle, this larger triangle, and then the area under the circle. So let's go ahead and section that out just so it's easy for us to see. Right? So got that triangle here. I'll cut it off over there. Got this triangle here. We got this triangle here. Right? And we got this big triangle here. And then we have the area under the circle. So we just kind of do this. And so just to kind of write out the work to show the work, we'll say, it's going to be the integral of -6 to 5, sorry, f of x dx. Let's zoom in so it's smaller. Minus the integral of -2 to 5 of f of x dx is going to be our answer, right? And so this is going to be 7 minus, and then we got to solve this, right? So let's actually go ahead and number these. We got 1, 2, 3 over here, 4, and 5 pieces, right? So piece number 1 is just going to be base times height is 1 times 1 over 2, so half. And then piece number 2 is also going to be a half, so it's going to be minus. Piece number 3 is going to be a quarter, and you can see because it goes you could either see that basically drawing the triangle again would give us half the square, right? So it's going to be a quarter of the square, so that's going to be 1/4. Or you can see that the base here is a half, so it's going to be a half times 1 over 2, which is going to be a fourth, so minus a fourth. And then this triangle is going to be 1.5 times 3, right? Which is going to be 4.5 over 2, or 9 over 4, so plus 9 over 4. Right, and then this circle here is going to be, well, it's got a radius of 3, we know that. So that's going to be a 2 pi r, pi r squared, which is going to be 9 pi, right? But it's only a fourth of that, right? So it's 9 pi over 4 is this circle. Let me just draw that in here, 9 pi over 4, right? But it's actually going to be this area under the circle, right, that I'm shading. And so that's going to be, this imaginary, well, I should use that again, but this square over here, right, which is it's a 3 by 3 square, so it's going to be 9 minus 9 pi over 4, right? So plus 9 minus 9 pi over 4. All right, now let's go plug it into the calculator. That gives us 3.069, which will be the right answer. Right? 3.069 is the right answer. All right, so for part 2, they ask us to integrate from 3 to 5, take the integral of 2 f prime of x plus 4. Right, so we can go ahead and start solving this. And so we can split that up into 2 pieces, right? 2 f prime of x and then 4. And for the 2, we can factor that out. So that would be 2 times the integral from 3 to 5 of f prime of x plus the integral of 3 to 5 of 4, right? And so for this, we're going to get 2 times the integral of f prime of x is going to be f of x, right? The integral of the derivative of a function is just the function. So it's going to be f of 5 minus f of 3. And then that's going to be plus the integral of 4 is going to be 4x. So it's going to be 4 times 5 minus 4 times 3. And so that's going to give us, let's do 2 times f of 5 minus f of 3. So f of 5 is going to be this 0 here. And f of 3 is actually going to give this point they gave us before. So f of 5 is going to be 0 minus 3 minus root 5. Watch your minuses over there. Make sure to use parentheses. And then plus 20 minus 12, right, which is going to be plus 8. And so that's going to be negative 6 plus 2 root 5 plus 8, which is going to give us 2 plus 2. Let's get rid of that over there. 2 plus 2 root 5. And if we want, we can plug that into our calculator. Get an answer of 6.472. There we go. And a quick note, I usually, I think for problems like, sorry about that. For problems like this, I think you might be fine not calculating it, but it's always good to do so just in case. So in part C, we're given that the function g, given by g of x equals the integral from negative 2 to x of f of t dt. And then it tells us to find the maximum value of g on the interval of negative 2 to 5, right? So basically, they're telling us that g is the integral of this function f, and they're telling us to find the maximum value. And so theoretically, that could occur at the start point if the entire function f was on the graph, or at one of the critical points, right? So that's going to be negative 1, half, and at 5, right? At all the zeros. So we've already solved this in part A, right, basically. So it's pretty easy to speed through. The integral at negative 2 is going to be 0. For x is negative 2 is going to be 0. If x is negative 1, right, the integral is just going to be a half. If the integral is, if x is equal to a half, it's going to be 1/2 minus 1/2, and then minus 1/4, so it's just going to be negative 1/4. And so looking at x equals 5, that's going to be the integral of the entire graph, which was at least part of the answer to part A, which was 11 minus 9 pi over 4. And you can just tell graphically that that's going to be greater than, at least greater than a half, right? And we can check that against the calculator just in case. Which gives us 3.93, which is going to be greater than a half. So it's going to be, at x equals 5, it's going to be the global maxima, and it's going to be this. Now in the final part, they ask us to solve for this limit. And so basically, as far as this problem is concerned, we can plug in 1, right? So it's going to be 10 to the 1 minus 3 times f prime of 1. So it's going to be the slope of f of x at 1 over f of 1 minus arctan of 1. And so 10 to the 1 is going to be 10. The slope at f of 1, right? So we go up here and we see that's going to be right over here. And the slope over here, the rise over run is 4 and the run is 2. So it's going to be 2, right? The slope is going to be 2. So the derivative at x equals 1 is going to be 2. So it's going to be 3 times 2 over f of 1. We go back here and we see f of 1 is going to be 1. 1 minus arctan of 1. And now we can go ahead and plug this into our calculator. So that's going to be 10 minus 6 over 1 minus arc tan of 1. And we want to make sure we're in radian, which we are right now. So that's going to be 18.639. Which is the correct answer.